Okay, let's take a look at number 8, where I've got this contour plot and I want to use that to find out some information about limits. So for this first part, part A, we want to determine the limit as x goes to 0 of f of x0. Notice that that does not say the limit as x goes to 0 of f of xy. F of x0 means that we should be looking at f of xy along the line y equals 0. So we want to first do that, and then second, once we figured out what specific part of the contour we're looking at, then we're going to let x approach 0. And that's what the limit is telling us to do. So I'm looking at this, what does y equals 0 look like? Here's the regular line y equals 0. And it just so happens that this is a line that matches something that already lives in my sketch. But I want to be clear that if it had told me to take a contour along y equals 1, then I would draw the same picture. I'm just going to interpret these pictures differently. So the difference is that this is equal to 10, and then here it's 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 equal to 10. Whereas if I was moving along y equals 1, I would say here it's equal to 9, and then here it's equal to 8, and then here it's 7, and then here it's also 7, so maybe it's less than 7 in between, and then here it's 8, and here it's 9. So either way, I'm going to draw my nice horizontal contour, but one of them is somewhat better behaved than the other. So I've got the line y is equal to 0, and I want to consider how the function behaves along that line as I let x go to 0. So what the 10 is telling me is that f of, say, -2, 0 is equal to 10. F of -1, 0 is equal to 10. F of 0, 0 is equal to 10. F of 1, 0 is equal to 10. F of 2, 0 is equal to 10. Each and every time I'm getting a 10. Maybe I shouldn't have said that that middle one was, because it's a little ambiguous what's happening there, but it is certainly true that as I approach x equal to 0 along this line, I should be getting constant 10s because it really looks like f of x0 as opposed to f of xy is equal to constant 10, in which case the limit as x approaches 0 of f of x0 should also just be 10. Now let's compare this with B, which asks us to determine the limit as x and y both approach 0. So I actually already know from part A that if the limit exists, if this limit exists, it should be equal to 10, because if I approach along the line y equals 0, I get a limit of 10. So my question is, if I approach along another line, will I get another value? So you probably already know what line I want to approach along. It's x equals 0, because the first things I always check are y equals 0, x equals 0, and x equals y. So if I try approaching along x equals 0, well, I can approach from above or below. If I do it from above, it looks like I go from 7, I go down to 3, and I keep going down. So I don't think it's going to be 10. It's a little ambiguous. I don't know for sure, but it seems like it's probably less than or equal to 3. And if I move up, again, I'm not entirely sure. It looks like it's going to be greater than or equal to 4. So approaching along x was not necessarily a bust. It's just making me think, this limit may not exist. And to confirm it, let me check another path. Let me check, say, x equals y. That looks like it's gonna hit the contour 8 and then stay on the contour that's giving me a value of 8. So I would say if I approach along that line, then I would expect the limit to be equal to 8. But it can't be equal to 8 and also equal to 10. It also can't be less than 3, but also greater than 4. And if I think about it a little more, I should get the same limit no matter what path to 0, 0 I take. And I can see there's a lot of different paths I could take that would give me different answers. So if I follow along this path, I would expect to get 9. But if I follow along this path, I would expect to get 5. So it definitely matters in this case, the path that I'm taking. And since the limit changes value depending on that path, it follows that the limit does not exist. And then finally, I'm going to look at the limit as xy goes to 1, -2 of f of xy. This one should be nicer because I'm not going to 0, 0, where I could kind of tell just by looking at this one that 0, 0 is going to be a pain to deal with. In this case, I am looking at x is equal to +1, which is happening along this line, and y is equal to -2, which is happening along this line. And the point where they meet is about here, where it looks like I'm on the contour where f of xy is equal to 4. There's no ambiguity, there's no bad limiting going on, there's no contours crossing each other or making loops or anything nasty like that. So I would say unambiguously that this should be equal to 4. All right, that's it for me. Hope that helps and good luck tonight.